All right, so you've learned about degrees and you've learned about radians. Both of them are equal measures of measuring uh, rotational measure. So how do we convert between degrees and radians and degrees? That's what we're going to look here in this section. And to help us with that conversion, I'm going to introduce this idea of cancellation of units. So cancellation of units is a really helpful skill to develop if you're going to go further on, to any other higher class. So if you, or any other science or engineering class. So even if you take biology or chemistry or physics, a lot of the properties of things that you'll be doing calculations on are going to have units attached to them. So, in terms of maybe centimeters or nanometers or newtons, of force, things like that. Those are units that, if you do your calculations correctly, a bunch of those units should cancel out. And if they do cancel out, and the unit you want is the only unit left standing, you can feel pretty good that your answer is going to be correct. So I'm going to introduce this idea of cancellation of units with something very simple to start and kind of slowly build up from there. Okay, but what we are mainly focused on is this degree to radian conversion. Now, in order to convert from degrees and radians, what we need an equivalence. And the equivalence that we have and that we know is that 180 radians, I'm sorry, pi radians is equal to 180 degrees. Okay, this is probably the most significant relationship we've got. This will allow us to convert back and forth. And this equivalence is usually expressed as a fraction. So here we've got pi radians is equal to 180 degrees, or we can flip that and we can have 180 degrees in the numerator and pi radians in the denominator. And which of those two fractions you use just depends on the scenario that you're in. And whether you use, radians on top or radians on the bottom is going to depend on how you want the units to cancel. All right, so cancellation of units. There's two basic rules. Rule number one, position the unit of interest in the numerator. Rule number two, position all other units such that all other units cancel out. So the only unit you want left standing is your unit of interest. So let's look at this idea of cancellation of units with this first example. So we want to convert 225 degrees into radians. So radians is what we're trying to find. That is what we call the unit of interest. We want to make sure that this unit of interest, radians, is in the numerator. So what equivalence, what uh, numerical fact do we have at our disposal which has radians in the numerator? We're trying to convert radians in degrees. Well, one of our givens is 225, but that's 225 degrees. The other one we have to work with is this fraction. And notice this fraction has radians already in the numerator. So that's what we're going to use. Pi radians is equal to 180 degrees. Okay. So radians is our unit of interest, and it is in the numerator. But our problem is that we still have degrees as a unit that isn't yet canceled out. So what other data, what other information do we have that we could use to cancel out degrees? Well, we have this 225. Well, where do we put 225? Do we put 225 in the numerator or do we put it in the denominator? Well, where you'd want to put it is going to be in the numerator. Okay, and you might ask, why does it matter? Well, think of if you were trying to simplify this fraction, right? You'd write 4 as 2 times 2 and 6 as 2 times 3. And when you're reducing a fraction, what is it you try to do? You try to cancel one factor in the numerator with one factor in the denominator. Well, this process of canceling like factors in the numerator and denominator also works with units. So if we have units of degrees in the numerator and we have units of degrees in the denominator, these units cancel. Just the units, not the number, just the units. And so with what we have here, we've completely canceled out the degrees, and the only unit we have left is radians, and radians was our unit of interest. So what this means is we can multiply everything that's left in the numerator and divide it by everything that's left in the denominator. And that'll be our answer. So we can write, okay, so if you were just to enter this into your calculator, let me go ahead and do that. So we've got 225 pi, oops, 225 times pi, sorry, and then divided by 180. You can see that that gives us 3.93, or more exactly, 5 pi over 4. So where did 3.93 and 5 pi over 4 come from? Well, 3.93, obviously, we just did this part on the calculator, and it came out to 3.93. But where did that 5 pi over 4 come from? Well, if we take 225 and we do a factored tree of that, so we take 225 and we divide by 3, we get 75. Divide by 3 again, we get 25. Now we can't divide by 3, so we can divide by 5. So 225 is 3 times 3 times 5 times 5. That's going to be times pi radians. And what about 180? That's 2 times 90, 2 times 45. Let's see here, 3 times 15 and 3 times 5. So 180 is 2 times 2 times 3 times 3 times 5. That's what 180 is equal to. And just like I mentioned up above, is we can cross out common factors. So we can cross out 1 3 in the numerator with a 3 in the denominator, another 3 in the numerator with 3 in the denominator, a 5 in the numerator with a 5 in the denominator, and that's about all we can cancel. And notice the only thing we have left is 5 pi radians over 4. So 225 degrees is equal to 5 pi over 4 radians. Now, sometimes you will be required, to give a fraction as an answer because a fraction is more accurate. This 3.93, I put those wavy lines to show it's approximately that because I'm rounding. So you're losing a lot of this value off to the side when you round to 3. Okay, so that's where 5 pi over 4 comes from. Okay, so use this example as a model, and it's also a model of unit cancellation, as well as factoring numbers into their prime factors and canceling common factors. Use this as a model to convert 315 degrees also into radians. Pause the video now and give that a try. Okay, so let's take a look at this. Radians is our unit of interest. So we're going to start with using this fraction, pi radians all over 180 degrees, and we're trying to convert 315 degrees. We want to make sure 315 degrees is in the numerator, so that degrees cancels with degrees. And let's go ahead and do the prime factorization of each of these. So 315, can't divide it by 2, so we'll divide it by 3, and that gives us 105. We can divide that again by 3, and that gives us 35. And then we've got 5 times 7. So 315 is 3 times 3 times 5 times 7 times pi radians all over. And 180, we did that earlier. So that was 2 times 2 times 3 times 3 times 5. Yep. All right, now we can cancel out common factors. So 3 with a 3, 3 with a 3, 5 with a 5. And what we have left is 7 pi over 4 radians. And if you take 7 pi and divide it by 4, you're going to get approximately 5.50. So 315 degrees is equal to 7 pi over 4 radians. All right, and likewise, we can convert back. So now we're trying to convert radians into degrees. So now degrees is our unit of interest. So if our unit of interest is degrees, we want that on top. So what we're going to use now is this version of our equivalence because we want degrees to be on top. So we have 180 degrees. That's equal to pi radians. And what we've got is 3 pi radians over 2. And radians will cancel with radians, leaving us with just degrees left over. And we can go ahead and maybe divide 2 into 180. That'll give us 90. And we have pi in the numerator here, which will cancel with pi in the denominator there. So we've got a lot of cancellations done. So all we have left is 90 times 3 in the numerator, and everything in the denominator has been canceled. So that just leaves us with 1. And 90 times 3 is 270 degrees. So 3 pi over 2 radians is equal to 270 degrees. Okay, give the next think, pair, share a try. Pause the video now. Okay. Oops, I apologize for that. All right, so let's look at this one, converting into degrees. So using cancellation of units, we want degrees to be in the numerator. So we're going to use 180 degrees is equal to pi radians. And we're trying to convert 5 pi over 6 radians. So radians cancels with radians. Pi cancels pi. And let's do 6. We'll go into 180 30 times. So what we're going to have is 30 times 5. Comes out to 150. Oops, should have put degrees in there. All right, so 5 pi over 6 is equal to 150 degrees. Oh, radians. Got to put my units in there. All right. Now, what about this next one? Here you might have thought, oh, Dr. Morales, this is just overkill. I'll just take pi, multiply by 315, divide by 180, and I'm done. Okay. And, again, I'm keeping the examples simple to demonstrate the idea. Now, where it starts to come into play, where it's a little more handy with cancellation of units, is when you're trying to convert units like this. So 1.257 radians per second, we want that to be degrees per minute. Think about that for a minute. It's actually a little harder. Now, again, you might think I could just Google it. Okay, you can. But we're not trying to learn how to use Google. You're learning how to use your brain to figure these conversions out. You need to develop the number sense. You need to develop the skills that this unit conversion will help you master, by doing this type of thing. So you do want to learn how to do this for yourself. Okay, so what we've got here are 2 units of interest, right? We've got degrees. That's a unit of interest. And we've got minutes. So that is another unit of interest. Actually, I'm going to need this room. So minutes are also a unit of interest. So I would say, start with one that appears to be the easiest and work from there. And so let's start with degrees. So we know that we've got 180 degrees is equal to pi radians. Okay, what do we have at our disposal that we could use to cancel radians in the denominator? Well, we have this given information here, and it has that unit of radians in it. So let's go ahead and use that. So we'll put 1.257 radians there per second. Extend this out further. Okay, now this is wonderful. So radians will cancel with radians, and that leaves us with degrees, which is one of our units of interest. So we've taken care of the degree conversion right now. Now what we need is we need to convert seconds into minutes. So we know that 60 seconds is equal to 1 minute. So let's put 60 seconds is equal to 1 minute. And seconds will cancel with seconds, and that leaves us with our second unit of interest, minutes, in the denominator. So let's go ahead and carry everything across. We have 180 degrees times 1.257 times 60. And that's divided by pi minutes. So you can see that this calculation we're going to do is in degrees per minute, and it's just using all the values that are left over. Now, if you multiply everything in the numerator and divide by pi, what you're going to get is 4,321.25 degrees per minute. All right. Now let's kind of maybe put that in context, because boy, that's such a huge number that looks like that's wrong. But let's take a look at our original problem. So our original problem had this value of 1.257 radians per second. Well, we know that if we go all the way halfway around a circle, that this is 3.14 radians. So 1.257 is about a third of the way around. So it's about there. This is about 1.257 radians. And whatever this is that's rotating, it rotates that far every second. Well, if it rotates that far every second, then in about 6 seconds, it's going to go all the way around, approximately. So when we're converting these radians into minutes, to degrees per minute, when we're converting it from radians per second to degrees per minute, because we're in minutes, and it goes once around in just about 6 seconds, well, it's going to be 10 times that number when we convert it into minutes. So we can expect this angle measure to be large because we're going to have multiple rotations in there. So let's take our answer of 4,321.25 degrees, and let's divide that by 360 degrees, right? 360 degrees is the number of degrees in one rotation. And what we get is that is approximately 12.00 rotations. So this is equivalent to about 12 rotations per minute. So whatever it is, the axle of a device or something that's spinning around, it's going around at about 12 rotations, full rotations around every minute, or 1.257 radians per second. All right. So this is, maybe a more advanced question using unit conversion, specifically angular unit conversion from radians into degrees. This next one is purely a cancellation of units exercise, where we're trying to convert 1,000 inches per second into miles per hour. And again, you could just Google it, sure, but you won't have access to Google on an exam. And again, we're trying to sharpen your skills, sharpen your brain skills, enabling you to think about this and do the conversion yourself. So we have two units of interest. We've got miles and hours. So go ahead and pause the video, give this a try, and resume when you're ready. Okay, so we're back. All right, so this is our unit of interest. Let's just start with that. So we know that 1 mile is equal to 5,280 feet. Let me give myself a little bit more room there. All right, now we're trying to get miles and convert it to inches. So this lets us go from miles to feet. Well, we also know that 1 foot is 12 inches. And by making that conversion, feet will cancel with feet. All right, that's good. But now we got miles still in the numerator and we have inches in the denominator. So what could we use to cancel those units of inches? We have our given information. 1,000 inches per second. So now inches will cancel with inches. And the only unit left standing, as far as distance goes, is miles. So we're good there. But we want to have our other unit of interest, which is hours. We want that to be in the denominator. And right now we've got seconds. So we could put in, use a different color, 60 seconds is equal to 1 minute. Okay, seconds cancel with seconds. Okay, but we don't want minutes in the denominator. We want our unit of interest, which is hours. So we've got 60 minutes is equal to 1 hour. Now the minutes will cancel with minutes. And now we're left with our unit of interest in the denominator. So you can see here, we fully converted inches into miles and seconds into hours. And we know we've done it because we've canceled out all the other units involved except for our two units of interest. So now we just need to multiply everything in the numerator. So we've got our unit of miles times 1,000 times 60 times 60 all over 5,280 times 12 times our units of hours. Okay, and when you multiply all that out, you're going to get 56.82 miles per hour. So what this means is when you're traveling about 55 miles per hour, then you're approximately going 1,000 inches per second. That's the conversion. Okay. So at first, maybe doing some kind of unit conversion like this was really intimidating. You didn't know where to start, and that's it. You don't know where to start. So doing cancellation of units, learning how to do it, lets you start. And once you start, you can then just kind of proceed forward and cancel units and work your way through it. You need to know where to start. Start with one of your units of interest and go from there. Okay, let me know if you have any questions.